Okay, we're going to go on and get started so we don't keep you too late today. Welcome to New York ASBO webinar, New York's High Performance Schools. Your presenter today is Carl Thurneau. If you have questions at any time during the webinar, please either use the chat window to the right of your screen, or you can chat with Carl directly over the phone by pressing 7#. That'll notify me that you want to talk, and then I'll unmute you, and you can go ahead and converse back and forth with Carl. So, without further ado, Carl, please go ahead.
Okay. Good afternoon, and I'd be happy to lead you through what we think is a good school design process for New York State schools. As we go through the presentation, as Matt said, if you have any questions, I'd be happy to answer them as we go along. So that's myself. If you're not familiar with me, I'm the Director of the Office of Facilities Planning, and we're in charge of all school construction permitting outside of New York City. So if you have any questions, call our office, and we'll be happy to answer your questions. Every school district has a project manager assigned to them, so we can get you to the right person to get your questions answered. The Green Schools movement in New York has its genesis way back in the early 1990s. The New York State Board of Regents passed a Bill of Rights for children. And the one most critical for this particular issue is that every child has a right to an environmentally safe and healthy learning environment, which is clean and in good repair. We've done a lot of work on that over the years, but it's important to keep in mind that, in our opinion, green schools or high-performance schools is just the next step in a long list of things that the Education Department and the legislature have been doing over the years to ensure that we have schools that are clean and in good repair. The rescue legislation was enacted in 1998. That also played a significant role shortly before we came out with our green school standards. Includes everything from a comprehensive 5-year building conditions survey, which most districts are familiar with and should have just completed in 2010. We also have annual visual re-inspections. Those are actually scheduled for elimination, actually, as a part of mandate relief. What we have discovered over time is that while the building conditions survey we think is extremely valuable to get districts up-to-date current information on the status of their facilities every 5 years, we found that the annual visual reinspection is not nearly as useful as the 5-year building conditions survey. So we have recommended that that be eliminated. It has not been eliminated yet. It does require a statutory change, but that is something we're working on. So once you develop a 5-year building conditions survey, we are asking in the regulations that a 5-year capital facilities plan be developed, and we would expect that that plan would emphasize critical priorities and health and safety items first. The legislation also includes monitoring programs, such as again, the annual visual, which is still currently in place, a comprehensive maintenance plan, health and safety committees, lots of different things in the regulation that are intended to help districts make sure that they're paying attention to critical safety and health issues during operation and maintenance of their facilities and during construction and reconstruction and maintenance projects. So, what is a high-performance school? If we kind of boil it down to the basics, we want healthy and comfortable learning and working environments. We want facilities that are less costly to operate over the life of the building, and we want to conserve important resources such as energy and water. When we talk about less costly to operate, quite often we are left with a certain budget, and we have to make the most of that budget, and it sometimes causes districts to make decisions that are not in the best interest of the long-term operation of the facility, yet it does allow the district to meet its budget, although in many cases with a less lived improvement, a less useful life, a lower performance rating or something of that nature, but less expensive, and therefore allows the district to maintain that budget. So we need to start looking at the overall life cycle cost of a particular improvement. Why is it important now? There's lots of reasons. As I'm sure most people are aware, there is a significant economic crisis going on at the moment. It's been going on for some time, and at least in the public sector, we don't see improvement to the tax base, for example, in quite some time. The state is suffering significantly, and we, as districts, are making decisions to reduce our expenses. So if you have facilities that are extremely costly to operate, suppose previously when those facilities are renovated, the decisions were made such that it reduced the long-term operating cost of that facility, you would therefore be paying less now, for example, to heat, cool, light, manage your facility. So we certainly want to take advantage of the latest technology when we move into the future in order to save additional costs in the future. We think that it's a better approach as you move down through some of those bullets. I'm not going to go through everything on every slide, but there's a better approach to school construction. Green construction is now the norm. When it was first developed, it was something new. It was something not well universally understood, but it is the state of the art now. And for example, all the architectural firms that routinely do schoolwork are certainly up on green design. There's different methods of achieving green design. This is New York CHIPS, which I should have mentioned earlier, is the Collaborative for High Performance Schools. It is a derivative of CHIPS California. And to back up even further, the U.S. Green Building Council is an entity that developed LEED. LEED is Leadership in Energy and Environmental Design, and that was a one-size-fits-all document. And so some folks in California said, hey, we'd like a design guide that's specifically for schools. So they developed the CHIPS, the Collaborative for High Performance Schools. As you can imagine, there's a lot of things that would work on the West Coast in sunny California that wouldn't be appropriate in New York. They have many schools with no corridors. You simply move from building to building outside because the weather's generally so nice. So we modified that CHIPS document with a permission from the U.S. Green Building Council, with permission from California. And before it came to New York, it went to Massachusetts. So we actually are working on a derivative from Massachusetts, and we made some improvements that we think are beneficial to New York. So the bottom line is green design and green construction should be the norm, and you should not, if your architect is looking at you a little bit cross-eyed or strange when you ask for some examples of what they've done, you might want to ask some more questions and keep looking, because you should not be paying for the learning curve for the architectural design firm at this point in time. Okay. New York CHIPS is a point rating system, as LEED is. There's 133 points, and we suggest that you need to maintain achieve a minimum number of points, 65, in order to be a New York CHIPS school. There's some that are mandatory. They are required, and then there's some points that are optional, depending on how your particular facility exists, its age, its types of systems, and so forth, and where it's located on its site, all different kinds of things. Not all schools will be able to achieve all points, and again, there are many things that are site-specific. But in general, it is a point system. The more points you can gain, the higher performance your school should be. Another thing I should have pointed out earlier is that this is a manual that was developed for use by schools, but it is not currently required. It is anticipated at some point in the future. We are not sure when. We don't have a specific timeline, but it's entirely possible that at some point in the future, a requirement would be in place that all new school design projects, renovations, constructions, etc., would be required to be in compliance with one or another green design standard. Okay. CHIPS is an SED document. It was developed by the State Education Department in cooperation with NYSERDA, and significant funding and research by NYSERDA. And as I mentioned, it's self-certification. It's not required at this point, and we do encourage districts to adopt as many of the features as they can. And a number of districts have passed board resolutions where they indicate that all their future construction will be in compliance with a high-performance guideline. What are our priorities in this whole operation? Again, if we go back to the beginning, where the regents are encouraging that, are claiming rather, that all children have a right to an environmentally friendly location, then what are our priorities? We want to ensure, first of all, that we have outstanding teaching and learning environments. So better natural and artificial lighting. If we have better natural lighting, we can not only reduce our energy dependence, but we can improve the quality of the lighting, which has been shown in numerous studies to improve learning and certainly make facilities more enticing for teachers and other employees. Provides long-term benefits to students, teachers, and taxpayers. Multi-use, flexible, and community space is appropriate. And I spoke briefly about this, life cycle operation and utility cost savings. If we can put in exterior walls that are of solid masonry or block and brick veneer, as opposed to brick face with metal studs and sheetrock on the inside, the masonry is a much longer life cycle material. It's lower maintenance over time. It is a solid insulator. It doesn't support mold growth and so forth. All those things lead to a much longer-lived facility with much less operational and maintenance costs, and that is just one example, being the exterior walls. So those are the priorities. We want to reduce our costs by providing long life cycle and low maintenance materials, while at the same time improving the teaching spaces that we're providing. We want them to be durable. They need to last 30 years. As we see now, there are many facilities in some of our larger cities, like Buffalo, for example, is currently undergoing a massive renovation of the bulk of their facilities. And we have 80, 90, and 100-year-old facilities that were very solidly built out of masonry and are being retrofitted for use in the 21st century. And they're great spaces, as opposed to some of the numerous school districts or school buildings we saw built in, say, the baby boom of the late 50s and 60s, which are in many cases being torn down simply because the work to return them to a state of good repair is some cases more than the value of the building itself. So let's tear it down and start over again. We don't see that with the much older buildings. They were built to last 70, 80, 90, 100 years, whereas those built in the mid-century were clearly not built with that long-term goal in mind. So if we have a new facility, for example, there are circumstances where we have seen buildings deteriorate to the point where there's a significant discussion about whether they should be saved even before they're 30 years old and before they're even finished being paid for. We need to prevent that in the future. They need to be easy to maintain. Low maintenance materials, low chemicals. There are many, many decisions and choices that can be made that lower your operating costs and your utility costs. Glazed block walls, for example. Many older schools have concrete block walls. They need to be painted on a regular basis, either every summer or every other summer, every third summer by the maintenance crew. Glazed block, while initially more expensive, is a permanent surface and does not ever need painting. So, for example, in the state education departments recently, as most people know, been significantly involved in Roosevelt schools, and all their new elementary schools have glazed block walls, such that, for example, that eliminates an annual maintenance cost to the district and labor cost, because now none of those hallways, corridors, large group rooms, cafeterias, etc., need to be painted in order to maintain them properly. Simply a clean rag and wipe down, and those blocks look like they're brand new. So there's another example. As we can move down this slide, school facility materials and systems create an environmentally safe interior environment. There's lots of things in place now that have low VOCs, low off-gassing of chemicals, low formaldehyde, low vinyl content. All those things have been shown to contribute various types of pollutants to the indoor environment. So if we can reduce those pollutants in our materials, then that has the impact of achieving better indoor air quality over the life of the facility. And then finally, we want to maximize the use of natural resources. If we're building a brand new building or an addition, then we can orient that addition to take advantage of the site's natural features, including prevailing wind direction, sunrise, sunset, etc., shading of the facility by trees or by landscaping, built into a hillside to conserve energy on the built-in side and so forth. There's lots of different design features that can come into play based on the type of site and the slope of the site and the orientation of the site. And those are important things to keep in mind as you design a facility. Moving along, additional priorities. We've talked about long-term savings, and that's a critical piece. I did mention this earlier. Sometimes we are very short-sighted in that we look at the first cost versus the long-term cost. I think that most of us probably went to school in a building that had terrazzo floors. And those are masonry, epoxy masonry floors that last the life of the building, 100 years or more, with very little upkeep. They look terrific after that length of time. They certainly are more expensive to put in. But again, they never need to be replaced throughout the entire life of that facility. On the other hand, many of the floors that we put in now or in recent times are VCT, vinyl composite tile. Vinyl composite tile can wear out several times in the course of a building life and need to be replaced. So if you replace a floor 2 or 3 times, then that cost for that replacement, that capital investment 2 or 3 times over the life of that floor or that building, needs to be considered during the analysis of the original cost of that building. So, for example, the terrazzo floor might be more expensive initially, but when you consider the fact that it does not need to be replaced 2 to 3 times over that life cycle, and additionally, if you know a little bit about floor maintenance, it costs about 20 cents a square foot to maintain terrazzo a year, whereas it costs approximately $1 a square foot to maintain VCT properly a year. So when you multiply the maintenance cost 5 times for vinyl as opposed to terrazzo, and when you consider that terrazzo never needs to be replaced at the same time that the vinyl might need to be replaced 2 or 3 times, then very quickly you can see that the cost of terrazzo over the life of the improvement is going to be much lower than vinyl floor, even though it is much less expensive to install vinyl initially. And that's what I talked about earlier about sometimes our decisions are short-sighted. We have a budget that we need to deal with, and by choosing a less expensive floor, we can certainly meet our budget, but what are we doing to our future expenses? That discussion doesn't even include the fact that vinyl is a pollutant. It costs a lot of money to manufacture, and it has end of life disposal problems because it's very difficult to recycle and it ends up in a landfill. Whereas again, terrazzo is a masonry item that could simply be ground up and used for many, many different purposes. Everything from concrete fill or subbase or road substrate. There's many uses for that in the construction industry. Those are examples of how deciding what materials should go into a facility can have significant impacts on the long-term operational cost of the facility. I think we have talked a little bit about this. We did say it's a voluntary certification process. It is not required. It is possible that it will be required in the future. It is initially when high-performance school guidelines were developed, there was an additional upfront charge. Designers had to provide documentation that their design was in compliance. They had to verify certain types of calculations and so forth. Those costs have basically diminished to zero now that high-performance design is a routine and known entity. It's a known cost, and the industry has worked hard to reduce those costs, and there should be no additional cost for getting a state-of-the-art design in today's market. again, this study is several years old now, but there was a significant study that studied more than 30, I think it was 33 actually, high-performance schools. At that time, this is 6 to 7 years ago now, the cost was 1.5% to 2.5% more. However, the next bullet demonstrates the significant advantage. Even though it was 1 or 2% more up front, the financial benefits were 10 to 20 times the cost of the improvement over the life of that improvement. Savings accrue from reduced energy, water, sewer, reduced equipment maintenance and sizing of initial equipment, the wear out, the reduced building liability, and so forth. So all of those items can have an impact on the cost of that facility. Again, the point that I would make is the first bullet in our mind has basically been reduced to zero. There should be no additional cost to receive a high-performance design in 2011-12. Okay, there are some additional things that you might be interested in paying for. We think it's a good idea. Commissioning. Commissioning is basically at the tail end of the project, getting a third party in to review the design detail, to review the installation detail, and to just simply verify that the design is working, the finished product is working as the design intended, and that everything is operational and working collaboratively to provide you the finished product. That's everything from heating and ventilating and cooling systems. You don't want to necessarily be heating one wing of the building when the outside temperature is such that you could get free cooling by, using a ventilation system to bring that heat in. All those kinds of things are very critical. The best high-performance school in existence will not save you any money if it is not operated once it's designed and completed and verified, if you do not operate it in accordance with the design parameters and in accordance with the goals set out during the design process. That's most important for the district to be involved in. You need to understand how the future design is impacting your operation and how you intend to use the facility so that the designers can design around those goals. There are 7 sites, or 7 subcategories within CHIPS, and they each have different numbers of points. So briefly, you can see what these categories are. The most important, of course, are energy, materials, and indoor environmental quality. Energy, obviously, we're all familiar with. It's a significant impact to our operational costs. The more we can design an energy-efficient building, and that's taking care of everything from the supply side, if you can buy in bulk, if you can manage your delivery costs, your peak loads, if you can manage the efficiency of the building itself, if you can use less energy, that's going to save significant amounts of money over the long term. Materials, again, we've talked about. High-performance materials are available in many, many categories. The industry has really come up to speed with these types of things. Sheetrock, how many districts have sheetrock in and that gets wet? You can potentially grow mold, etc. There are sheetrocks now available that do not have a paper face and therefore cannot support mold growth. That alone is a huge improvement in the technology for a very common construction material. Indoor environmental quality, of course, is also equally important. There was a time in the 70s when the oil crisis hit that districts and everybody else, for that matter, closed up their buildings so tight so that they didn't have to use energy, and that created indoor environmental quality issues, everything from high moisture, which creates mold and allergen problems, to not having enough fresh air and ventilation and causing stuffiness. And to this day, in 2011, we occasionally find districts that have no fresh air coming into classrooms because their unit ventilators were boarded up in the 70s and literally have never been uncovered. So lots of room for improvement. We just think it's important for districts to understand and really take a hard look at how they operate and maintain their facilities. Operations and maintenance is a section that is unique to New York. We do believe that this is a significant piece that is different from the other high-performance guidelines. And as I've mentioned several times, operations and maintenance is critical to your bottom line as far as your facilities are concerned. And then there's some extra credit things that you can try some new and different technologies if your board's interested in going that direction. I don't know that I want to go through or spend too much time on the scoring system itself, but the bottom line is, as has been mentioned, there are prerequisites, there are credits, and we currently suggest that 65 credits would be required for a self-certified high-performance school building under the New York CHIPS guideline. Here's some information on site, for example, and this is how the building, this is how the document is broken down. So the prerequisite would be code compliance, and that shouldn't be difficult because, quite frankly, that's one of the things that my staff will require when we review your project in the first instance. So it's called a prerequisite, but it's really it's a minimum level of compliance that would be expected anyway. And it is important to point out that the code itself is a minimum standard. When we see projects, excuse me. Sorry about that, folks. Thought I was going to sneeze. When we see projects come in with code compliance, we sometimes need to remind districts and designers that that is a minimum standard. That's the bare minimum that a district needs to do to meet the code and obtain a building permit. There are often many opportunities to exceed the code at very little money and yet still, and thereby still increase substantially the energy efficiency. Okay, I got that out of the way. Thank you. Increase the energy efficiency, increase the ability of the building to conserve water or anything along those lines. It's important to remember that the code is a minimum standard. And so New York CHIPS provides lots of opportunities to go beyond the code. So what do we want to do for our site? A lot of this is, quite frankly, common sense. We want joint use of facilities. I don't think there's a district out there that doesn't have joint use of facilities yet. I know my own district. I play adult volleyball. My kids are over there in the evenings for other various activities, whether it be sports, whether it be a church group use of the facility, any number of different things. Most districts have joint use of facilities, so let's make that a prerequisite. For the environment, we want to do no damage, basically. Why should we continue to develop wetlands? Wetlands have been shown to be a critical component of our environment. We need them. Let's not fill them in. Let's not develop them. We don't want to develop on parklands if there is any other option available. We don't want to build on floodplains, as we unfortunately have seen in New York this spring and this fall. That creates massive problems. We've had a number of districts in severe flooding conditions this year. And in the future, when we select sites, if at all possible, we should not be going anywhere near floodplains. Credit for reducing a building footprint. For a lot of reasons over the years, school districts never built up. We see, 500,000, 600,000, 800,000 square foot buildings all on one floor. If we think about that, you basically have developed twice the land. You've got twice the footing, twice the roof. You can save significant resources by even building a two-story building as opposed to a one-story building. And there's nothing to prevent a three-story building, as we are starting to occasionally see. All those, the farther up you go, and of course there is a happy medium. You certainly don't want to be putting a high-rise out in the middle of the cornfields in rural areas, but there is a happy medium, and significant resources can be saved by reducing the building footprint. Stormwater management and other things that can be done, but bottom line is that's an example. Site is a fairly small category, but there are certainly things you can do. Now again, not every district is going to be able to get these because your building may already exist. You're just putting in an addition, so you can't necessarily, if you're already developed on a floodplain, you can't avoid that. So you wouldn't be able to get that credit. But there may be other things that you're entitled to. Water is the smallest section. There is opportunity to save water. Let's put in natural landscaping that is designed for the area that the school is in. You might therefore not need to irrigate it. You can reduce the cost of the initial irrigation. You can reduce the amount of water you use if you don't have irrigation. Indoor water use reduction. There's things like low-flow toilets and waterless urinals now. And not only do they save water, but they save capital investment, because if you think about what's behind the wall, you no longer have to run piping and insulation and valving to all those urinals. I mean, in a typical large school, you might have, 60 urinals when you add up all the various bathrooms around the facility, plus the boys' locker room and all those kinds of things. If all of those were waterless, think of the capital investment that's avoided by not running cold water piping and valving and insulation to all those locations. Those are types of things that can and should be considered. Then we get into the energy efficiency, and again, there's much more detail there. Exceed code by 20%. That's not difficult, believe it or not, because again, the code is a minimum standard. The state does look at improving the energy code over time, but it generally does not keep up with the pace of technical advancement, and therefore it remains relatively easy to exceed code by 20%. Then that's a prerequisite, exceeding code by minimum of 20%. So therefore, that should give you an indication of how easy, in fact, it is to beat the minimum standard, because we require it as a prerequisite. There's some other things. Commissioning, as I say, is a method of verifying that your facility is operating the way it's supposed to. As we go down through there, one of the prerequisites is a comprehensive maintenance plan. Well, that's already required by Commissioner's regulation. So that's not a difficult prerequisite to meet. You should have one in place already, and you cannot effectively maintain your facilities if you don't have a document like this that you can use as a living document. Let's go to the next. Materials. The prerequisite there is wallboard products. As I mentioned, there are new types of wallboard products that have no ability to support molds, so that would be a key provision moving forward. Then we get into things that are called LCC, Lifecycle Cost. I talked extensively about the example of terrazzo floor versus vinyl floor. Based on the lifecycle cost, the terrazzo floor is much less expensive. So we need districts to start considering those types of things when they are looking at the budget for a capital project. Waste reduction and sustainable materials. There again, sustainable materials is important. Masonry buildings can, as much as 75% of the actual building material can be reused when that building ultimately is past its useful life. That's a huge landfill avoidance and a huge cost avoidance, because it is significantly expensive to put things in a landfill. The tipping fees are extensive because nobody wants one in their backyard, and entities are having, like municipalities, are having more and more difficulty permitting new landfills, and therefore this cost will continue to increase. So the more you can reuse, the more cost-effective it's going to be to retire that facility in the future. Indoor environmental quality is very, very important. There's certain things like 5.1, daylighting and views. Some of that is just a restating of things that have been required in our manual planning standards, like access to views. For developing eyes, you need a distance view, which is why all our classrooms are required to have windows. And that's why courtyards get developed, in case some folks aren't aware of that. If you have classrooms back-to-back and they don't have that exterior view, then the children's developing eyes do not get that distance view during the day, which they need to develop strong vision. So in order to have all those classrooms on the interior gain access to views, that's how courtyards get developed, so that all those classrooms on that courtyard have an exterior view. Daylighting. Daylighting has been shown through either tall windows or skylights, or roof monitors have been shown to significantly increase the natural lighting, which decreases the need for electric lighting and can significantly increase attendance rates, test scores, etc. A lot of that evidence is anecdotal, but there are many studies that are showing improvements in everything from student performance, teacher performance, absenteeism, and so forth as a result of clean, healthy, well-lit classrooms with natural light. If we get into indoor air quality, there's so many things that are just plain simple, common sense. Walk-off mats and grills. I have 4 kids, and I know what a chore it is keeping up with all the shoes that are tracking stuff into the house. So I did take my own advice, so to speak, and I went out and I bought good walk-off mats, both for the garage and the back door and the back hall, and it's amazing the amount of stuff that comes off those shoes. If we do the same thing in our schools, if you have walk-off mats and grills at every entrance that are approximately 15 to 20 feet long, the longer the better, in your entranceways, and people clean their shoes as they come in, that has been shown to keep anywhere from 60 to 80% of the dirt out of a facility before it really gets in there. So if you bring in 60 to 70 or 80% less dirt, it's probably not a 1-to-1 ratio, but think of the money that you save by not having to clean all that dirt up and out of the facility. That's less floor chemical you might need to apply. That's less often you might need to strip and wax your floor, because the grit from the sand and the gravel does not chew up the finished surface. So simple things like that can have a huge benefit. That's more of an operational thing, to provide those walk-off mats and grills. In new construction, you can provide them built in, so they're recessed and you walk in and stomp your feet on the grill type thing. But in existing facilities, you can contract with mat companies that come in and change those on a regular basis. Lots of ways to control that. And you go down through the list, and there's many other things that we do require as a prerequisite, but again, they're not difficult when you're designing a new facility. And then there's different credits that you can obtain. Indoor air quality during construction. First of all, you have to have an indoor air quality plan, mold protection, filters during construction. All those things are prerequisites. And then during construction, if you ventilate VOCs outside, if you're getting new carpeting, for example, and you require that the contractor take that to a warehouse and unroll it for a week and let it air out before you bring it into your school, all those off-gassing VOCs that are going to happen in someone else's location that are vented to the outside, hopefully, as opposed to happening inside your school. So the more things that you can include in the construction, then the better off your indoor air quality is going to be. Going on through time, if you have outfitted all your maintenance personnel with HEPA vacuums, then again, that's an excellent filtering device that will trap fine particulate and prevent it from being put back into your indoor environment. Acoustics, minimum acoustic performance is a prerequisite. Many school districts have ventilation systems that were built with unit ventilators in every classroom. They're loud, they bang around, they're noisy and in some cases as noisy as a teacher. So if you're that row of students that are sitting next to the windows, it's from a listening or acoustical perspective, it's like having 2 teachers talking into different ears at the same time. You're trying to listen to the teacher at the front of the classroom. At the same time, you have this mechanical teacher talking in your ear with background noise. And it makes it very difficult to concentrate. So if we can avoid that system altogether and go with a central system on the roof and ducted supply and return, then you will significantly increase the acoustical performance and remove distractions from the classroom. And we'll see in a minute, in a future slide, another reason that it might be critical to remove HVAC systems that come through the sidewall like that. Let's see. Let's move on. O&M, as I mentioned, this is a new section for this is a section for New York CHIPS that does not exist in the other documents. Prerequisite, an energy plan. You really have to have an energy plan. If you don't know how much energy you're using, in what frequency, if you don't know what energy options are available, you can't reduce your energy. If you don't know your benchmark, suppose you have a 100,000 square foot facility, and just throw out some numbers, you're using $3 a square foot. And maybe that's good, maybe that's bad. Maybe there are comparable districts in the 3 or 4 districts around you that are only using $2.50 a square foot. You would want to know that, and you would want to know why your energy usage is higher than theirs. It may be unavoidable because of the design of your facility, or it may be something that you say, I didn't know that. All those districts are using this technology, and I'm not. And if I do, maybe I can significantly reduce, in that case, in that example, by, say, 20%. BOC training, building operators certificate. Buildings are complicated. Buildings are complex. A lot of things are computer controlled, energy management systems. So the more training you can provide to a professional facilities individual, it's going to increase the likelihood that your buildings are maintained properly, and when maintained and operating properly, they're going to be most effective. We also provide credit for a certified superintendent of buildings and grounds. The New York State Association for Superintendents of School Buildings and Grounds has recognized the need for professional development, and they have created a curriculum for their own members that the department has endorsed called the Certified Director of Facilities, the Certified Superintendent. And so that program is rigorous enough to us such that we know that the folks that have been through that training have significant knowledge in the proper operation and maintenance of buildings, and we believe that that is a credit that should be due to that district based on their willingness to send that individual to training. Maintenance prerequisite is a maintenance plan. That's, again, very obvious and something that's required by the rescue regulations. You can't properly maintain a facility if you don't know what equipment you have in a form that allows you to research how often the maintenance needs to be done. Maintenance plans can be simple or complicated. They can provide all kinds of spreadsheets, or they can be, a notebook if you have a simple district. But you do have to have a plan. You need to know what kind of pump you have and how often that bearing needs to be greased. You need to know how often that fan belt needs to be tightened on certain rooftop unit. And if you don't have a schedule to go around and do that stuff on a regular basis, you will not be operating at peak efficiency. Integrated pest management is also required by the rescue regulations, and here we say for maintenance, you need to purchase HEPA vacuums. That is a prerequisite in order to get those points. And then finally, there's extra credit. So there's everything from purchasing standards, performance monitoring, buying clean energy, wind or solar, alternative fuels, anti-idling measures. Again, some of these things are required by law already. Anti-idling of school buses, for example. But there are, and then innovation credits. There are opportunities to utilize new technology if it makes sense for the district to do so, to gain some additional credits. I should drop back just a little bit and talk about why we're interested in doing all this. The average school building is 55 years old. For those of you who have not seen this slide before, this is the Washingtonville Central School District several years ago. Catastrophic failure of a roof over a classroom, and thank God this was a Sunday afternoon. Had that been a Monday or any other, instructional day of the week, then it's entirely likely that we would have had some fatalities there. You can clearly see the blackboard and there's student desks buried under that rubble. That consists of roof joists, roof deck, insulation, and actual roofing. So significant weight that, again, catastrophic failure without warning. And those are some of the things that we absolutely need to avoid. And this is the type of situation that the Building Condition Survey is designed to protect against. We are requiring licensed professionals to go into those buildings every 5 years and review those building systems in detail so that we know what's wrong with that facility and we can prioritize in our comprehensive 5-year plan what the money needs to be spent on first. Here's another example. This happens to be a second-story auditorium wall over a first-story roof. The lower roof is actually the entrance to the auditorium. Again, catastrophic failure, no warning. It just collapsed. So, again, had, for example, people been walking in and out of that entrance, this isn't too bad compared to the last, but it's another example of why we need to be up looking at our facilities on a regular basis. This one, of course, is the most recent. This is Mount Vernon's High School. On the right-hand side, that wall with the vertical columns, that is a 100-foot long by 30-foot tall masonry wall. Once again, catastrophic failure, no warning whatsoever. The hole that you see on the left-hand side is the size of a small school bus. And that structure, that roof structure and all the masonry fell into a classroom. So no question in my mind that there would have been fatalities. This is a desk inside that space that you just saw from the hole in the roof. So again, those are the structural things that we're looking for in the Building Condition Survey. The more we pay attention to green design and green construction and the selection of proper materials and the life cycle cost of those materials, then the less money it will cost us to maintain those systems and materials over time, and hopefully things will not deteriorate to the point where catastrophic failure happens. This picture I threw in, I mentioned previously that in the future there'd be another example of why it might be a good idea to eliminate HVAC systems that come directly through the walls. This is a school that was recently flooded in the southern tier. And that ventilator you see on the wall under the switch is the air intake for a unit ventilator into a classroom. You can see the line of dirt on the wall. That was the flood level, clearly right over the top of the ventilation grate. So all of that dirty water poured right into every classroom in the building, right through the unit ventilator. Had this building been designed with a rooftop HVAC unit that had ducted supply and returns to each classroom, then although this still would have been a damaging flood, the water and the flood conditions would not have had direct access to every single classroom in the building. So New York CHIPS in summary, I think it's a very valuable tool. I think it is something that districts need to consider. The benefits far outweigh any initial cost, and we need to get over that concern about making sure that we can provide for the future by reducing. We need to make sure we can stop looking at first cost and making sure that we are making the best financial decisions for both the long-term health and vitality of the district as well as the taxpayers, but for the educational environment of the students as well. So that's basically the presentation. I only have one other little topic that I would include in this, and that is that while this document does encourage alternative energy sources, we need for that topic, we need for that discussion to make sense to both the district and the state in order to get state funding. There are a number of districts that have put in geothermal systems, ground source heat systems for heating and cooling. We have districts that have put in biomass boiler systems. We have districts that have contemplated wind turbines. We have lots of examples like that. And I just need to caution districts that you need to clearly consider all of the potential costs of that as well as the payback period. There are times when a biomass system makes a lot of sense, and there are times when it doesn't. An example of when it doesn't, excuse me, apologies. An example of when it doesn't make sense is when the district has a 10-year-old building, which is one example that I've dealt with recently. They had a 10-year-old building, and that building has the heating system that was requested by the district at that point in time. And they now believe that they could save significant operational dollars with the biomass system. And, in fact, they probably could. But the state can't afford, nor should the state be in a position of funding 2 heating systems for a school building within a 10-year period. In fact, there's nothing wrong with their current heating system. And as I say, since it's a new building, it won't be done being paid for another 20 years. So the state is not in a position to fund multiple heating systems at the same building across the state. So if it makes that much financial sense operationally, I think the district should move ahead and do it on their own. Beyond that, they need to be very careful about the systems that they select and put in place in the first instance. An example where a biomass system would make a lot of sense is we put one in a district up north where the building was old enough that they actually had an old coal bunker which was abandoned when the district went to oil and gas and so forth. But now that they want to put in biomass, the coal bunker becomes a perfect storage bin for the wood chips, and the old boiler room was large enough to house the new biomass equipment. So that's a perfect reuse and not a significant increase in cost over a traditional boiler system. If you didn't have that, then the district would be asking us to build a new facility for chip storage, for biomass equipment, and so forth. So it substantially increases the cost as opposed to a traditional heating system, maybe $1 million in that example. The biomass system might be $3 million. So that doesn't make a lot of sense. Let's not spend 3 times what we need to accomplish the same purpose, that of heating the facility. If it is that important to the district, in the future, the state will probably pay aid on the $1 million, and the district would take the remaining $2 million at their local cost. There are other examples like that, but each of those new energy systems or alternative energy systems, they have pros and cons, and we need districts to seriously consider those pros and cons and evaluate the true cost before they come and talk to us. So that's kind of high performance in a nutshell. I think it has some great opportunities for districts, not just for new construction, for reconstruction as well. If you're just putting in a new wall system or a new floor system or new lighting system, then you can evaluate those systems in a renovation just like you could in a new project. It does not have to be a large new construction project to be able to use high-performance design standards. You can still do those life cycle cost analysis and benefit cost ratio analysis on individual systems as you renovate your facilities. So with that, I think I'll stop there. It's 3 o'clock, and I'd be happy to answer any questions anybody has.
Great. Thank you, Carl. If anyone has any questions for Carl, please hit 7# on your phone. I will then put you right through so you two can talk. Please go ahead and do that now if you have any questions. Okay, Carl, we have Beth Gillette with a question for you. Beth, go ahead. Beth, you're on the air.
Hello.
Beth, you're good to go. Go ahead and ask your question, please. Okay, Beth, we can't hear you. If your phone is on mute, please take it off. And then ask your question again, please.
Hello?
Yes, hi.
Hi, Carl.
Yes.
Okay, Lou Bianchi, Greece School District.
Hi, Lou.
Carl, how you doing? Just a quick question. Your one of the slides you had regarding the 1.5 to 2.5% more. Are you referring to design costs there or construction-related costs?
That study, I believe, referenced the overall increase in cost. I'm looking for that slide. There it is. high-performance schools cost 1.5 to 2.5% more. Again, this was several years ago, and I have to look up the study again, but it was at this point in time, I'm betting it was 5 to 6, maybe even 7 years ago.
Okay.
And I think it was the overall increase in cost of the facility. That includes design costs, that included construction costs. We think that those costs have basically diminished to zero.
Okay. Yeah, I mean, we had been shying away from some of this for several years because of the additional costs, but it's good to hear that's coming down or gone, so we can redirect.
Some of those costs were because architects and engineers were concerned about the level of work that they would have to provide to the owner to justify or to verify to a high-performance entity that their design did, in fact, garner various points and therefore be certified if you're talking about LEED or something like that. So they were covering their additional work. Sometimes, as I mentioned, commissioning is often an extra cost. I don't necessarily believe it should be, but that's quite frankly the way the industry works. But the rest of the cost was in specifying new, quote, high-performance materials.
Right.
And many manufacturers are now offering, quote, green or high-performance alternatives. The wallboard is just the best example of that. I can't think of a greater improvement in a product that is so frequently used in commercial and residential construction. I mean, sheetrock that doesn't grow mold is huge.
Right.
But now that it's a standard offering by many manufacturers, the price has dropped accordingly.
Okay. All right. Thanks very much. Very nice presentation.
Good. Glad to hear it.
Thank you.
You're welcome.
Okay, we still have time here with Carl, so if anyone has any additional questions, please hit 7#. We've got Carl here for another 25 minutes, so ask away. Ask anything you've got there, please. Again, that's 7# if you have a question. Okay, last call, and then we're going to let Carl go. All right, Carl, no more questions for you. Thank you very much for presenting today.
My pleasure.
And I hope to see you all back on the ASBO webinar system soon. Thank you very much.
Okay, thank you.
The moderator has ended the conference. Goodbye. Thank you for calling.